our absolute value function, which is a very important function. There's our definition. That is the definition of absolute value of A. Absolute value of A takes on the value of A if A is a positive number or 0. But it takes on the value of negative A if A is a negative number. In other words, it's always positive. And what is it talking about? It's talking about the distance or the magnitude of the number. How far away is it from 0? The direction is not considered, because when we're talking about numbers, we're talking about the number line. Negative is really just saying, what direction am I heading in? I'm heading to that way. Well, it depends which way you're looking at the line, I suppose, but you're heading in the negative direction. There's some basic results. Some of them are a bit obvious, but the absolute value of negative x will be the same as the absolute value of x. Again, highlighting, we don't care about the sign, it's just the magnitude of the number, the size of the number. Magnitude of x minus y would be the same as y minus x. If you multiply, you could do it either way. You could find xy first, then find the magnitude of it, or just find the magnitude of x and magnitude of y and multiply them together. The same thing happens with division. Magnitude of x squared, I keep saying magnitude, absolute value of x squared would be the same as x squared, because it doesn't matter whether x is negative or positive. When you square it, it's going to turn out to be positive anyway. And this one here, the square root of x squared, which a lot of people just write down as x, but actually it's the absolute value of x. A lot of times it doesn't matter, but sometimes you do need to consider that. Alright, well, absolute value negative 5, so we're really saying, no, I just want the size of it, it's 5. You do the calculation inside there, 6 minus 8 minus 2, which is negative 4, that's 4. The absolute value symbols are grouping symbols, just like parentheses and brackets and braces. So the rules still apply. You do what's inside the brackets, the parentheses, the grouping symbol, you always do that first. So 6 times 3 minus 20, negative 2, 7 minus 2, we get 5. Again, as I say, they're grouping symbols. So it's no different to a piece of algebra. That's just saying 3 times whatever's inside these parentheses. In this case, absolute value symbols. 3 times 6 is 18. Alright, that now brings me to this question. The square root of x squared, if you know x is less than 0, well then the answer is negative x. And so that's what I'm saying. It's not always true to say the square root of x squared is x. It all depends on what is x. So in this case the answer would be negative x. The graphs, what do they look like? Okay, we deal with the linear function, the absolute value of mx plus b. But basically, how do you create it? You draw the line, and whatever is below the x-axis gets reflected above, because its sign is changing. And that's why, well, let's do the most basic one of all, y equals the absolute value of x, we get that classic V shape. Because really, what that is y equals x, but the bit below the axis has been reflected above. It means for y equals x, that would have to be a right angle, of course, because it's coming through at 45 degrees. When we draw these graphs, it's probably a good idea to put some sense of scale on it. Just labelling the origin is not really going to help me. So we might put a couple of points on each branch just to have some sense of the scale. So if I had to sketch the absolute value of x plus 2, a couple of ways of thinking about it. I could say, well, look, the basic curve is y equals the absolute value of x. I know what that looks like. What am I doing? Well, remember they're grouping symbols. So that plus 2 is grouped with the x. So I'm shifting it left 2 units. So it would go over there. And so those points I can plot in. That's one way of thinking about it. Another way I could think about it is I could say, well, the basic curve is y equals x plus 2. And the bit below will get reflected above. I end up with the same picture. There are 2 different ways of thinking about how we construct that picture. Whereas this one, y equals the absolute value of x plus 2, again, I'll draw in the basic curve and I'll shift that up 2, because now it's not grouped with the x. And we end up there. Solving absolute value equations. And I guess when most people look at this sort of equation, very simple one, absolute value of x is equal to 7, most people just think, well, x is plus or minus 7. Well, which is certainly true, but that's not how we should be thinking about it. We should be going back to the definition. So if I see one like this, I'm not going to say 2x minus 3 is plus or minus 7. I'm going to go back to the definition. Absolute value can equal either the positive of it or the negative of it. So therefore it's 2x minus 3 equals 7 or the negative of 2x minus 3 equals 7. Now you might think, well, what does it matter? And maybe in equations it doesn't matter. But when we come to looking at inequations, it can make a big difference. So that's what, just think of the definition. Let's go solve those. Left hand side one, that's x equals 5. Right hand side we get x equals negative 2. So we have our two answers. Then we really need to be careful with ones like this. Okay, either 2x plus 6 is equal to that, or the negative of 2x plus 6 is equal to that. Solve the first one, I get x equals 7. Solve the right hand side one, I get x equals negative 1. And a lot of people will go, oh, well, there's my two solutions. But we have a problem. What a lot of people do is they forget to do the most basic thing about equations, which we always say, and that is check your answer. X equals negative 1 doesn't work, because if you put it in the right hand side of the original equation, I get negative 4. It's impossible for absolute value to equal negative 4. So that is not a solution. Remember, when we break this up into two things, we're changing the question. We're changing the question to something else in order for us to be able to solve it simpler. So yes, it's an answer to the new equation that we created, but it's not an answer to the original equation. So anytime you change the equation to make life easier for yourself, you need to check, does it answer the original question? When we're dealing with this sort of thing, really the only thing that's going to happen, the only time it could possibly happen, is when we've got pronumerals on the right hand side. If I don't have pronumerals on the right hand side, I'm not going to have an issue because I'm not going to be substituting that negative number into it. But that's what we want to watch out for. 4D, let's add that to our list.